Hello everyone, welcome to my YouTube channel. I am Muhammad Talha and today we are going to work on a new machine learning project. Today we are going to develop a machine learning project that will predict whether a person has diabetes or not. And for that purpose we will use a machine learning model, a classifier that is called Sport Vector Machine, or SVM in short. So without further ado, let's just dive into this video. Okay, first of all, we are going to use Google Colab for this video, and for that what you have to do is, first of all, go ahead and mount your Google Drive with this Google Colab. And for that you can just go ahead and execute this cell right here and your drive will be mounted here, right? And now after that what we'll do, we'll just go ahead and import all the dependencies that we're gonna use in this project. First of all, we need NumPy because we are gonna deal with the arrays. So that is why we will utilize this very powerful library. Secondly, we will use Pandas because we have a dataset in CSV format, and we use Pandas to read that CSV file. Now after that, what we will do, we will use our machine learning classifier, and there are some other dependencies that we use for the sake of pre-processing the data, and for splitting the data into a test and train format. So for that we will use Sklearn library, and first of all what we have to do is we have to standardize our data, and for that we will import standard scalar from Sklearn libraries pre-processing module. After that we will import train test split method from Sklearn.model selection. Now this method right here will split our data into test set and train set. We will also import a classifier that is called SVM, and that is also available in our Sklearn library. And to predict or to measure that how much our classifier is accurate, or what is the accuracy of our result, we will import another method that is called accuracy score, and we will import it from Sklearn.metrics module. Okay, so we'll just go ahead and execute this cell. So all these dependencies are imported into our Google Colab notebook. Now after that what we have to do is we have to read the data set, right? Now I'll just go ahead and show you that inside of my drive I have this my drive, which is my Google Drive, and I'll just scroll down here, and in this machine learning folder I have this project called diabetes prediction, right? Now this is the CSV file that we want to read. So what you can do is you can just go ahead and right click here and you can copy this path, and after that you can just go ahead and remove this and paste here. Okay, so this is the path where your diabetes.csv file is actually present, and we will use read_csv method from Pandas. So that is why we imported Pandas earlier, right? Now after importing this data set, we will store that data set into the data variable. We can also call it a handle, with which we will handle our entire database wherever we want it inside of our project. So after executing this file, right now my data is stored in this data variable, right? So what I will do, I will just go ahead and check whether this dataset has been stored in my variable or not. And for that, what we can do is we can either we can just go ahead and execute this data, and it will give us all the data that is present inside of this variable. Here you can see our data actually has 768 rows, right, starting from 0 all the way to 767, sorry. And we have 9 columns. So the first column is pregnancies, the second column is glucose, third one is blood pressure, skin thickness, insulin, all the way to outcome, right? So this outcome right here actually shows us whether the person has diabetes or not. We have two classes here, two labels here. The first one is 1 and the second one is 0. Now this 1 here shows if the person has that the person has diabetes, right? And the 0 here actually shows that the person does not has diabetes. And these are all the input characteristics of a person that will decide whether the person has diabetes or not. For example, if a woman has 6 pregnancies and her glucose level is 184, her blood pressure is 72, skin thickness is 35, insulin that she takes is 0, BMI score is 33.6, and this value is 0.627, and her age is 50, then it's likely that she will have diabetes, right? And same goes for this second female that does not has the diabetes. Okay, so what we'll do, we'll just go ahead and pre-process this CSV file, and after that we will feed this data to our SVM model, which will predict that if a person has diabetes or not. So let's just go ahead and analyze this data, like its shape or its description. So what you can do is you can use this shape method here. When you will execute it, so basically this shape method actually tells you that in your CSV file how many rows that you actually have and how many columns that your data have, right? Let's just go ahead and see some statistical values. What you can do is you can just go ahead and use this describe method that will actually give you all these quantities, like this count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and max value. So if I just go ahead and remove this transpose, what you can see is these are the exact same values, but the rows became columns and the columns became rows, right? So actually this count here gives us the value after counting all the entries present in a column. So that means we have 768 values in the pregnancy column, and same goes for glucose column, and same goes for this insulin column, right? And all the other columns as well. And the mean, this value right here actually gives us the independent mean of all the values present in a column. So all the values that were present in the pregnancies, the average mean is 3.84, and same goes for all the columns, right? Now exactly like this, this is the standard deviation, and this is the minimum value. So the minimum value actually is the value that is the least inside of a column, and maximum value is the maximum value that is present in a column, right? Now this 25% means that 25% of the values are less than this value. 50 percentile means that 50% of the values are actually less than this value, and 75% of the values percentile actually shows us that 75% of the values are actually less than this value, right? So these quantities are actually have been measured independently on all these columns. So what you can do is you can just go ahead and use this transpose. It actually does nothing except it changes the dimensions. Column becomes rows and rows become columns, and you can see all the values more easily now. Earlier the column or the rows or the table was quite big, and you had to go through all the way to the right to actually see things. But using this transpose function, this is actually pretty much more clear enough. So we'll just go ahead and see the info of our data. So this method actually gives us all the information about our data, information about all the columns, like for example what type of values are present in this column. So we have integer values, right? We had the numbers like 1 pregnancies, 3 pregnancies, 6 pregnancies. So all these are numbers, so we have the data type of int. If we just go ahead and check this BMI, let's just scroll up a bit and see what is present in our BMI. So in this column we have a value that has floating point, right? All the other values are almost without that decimal point. So that is why we are using a data type of float here, because we are using this point right here. So you can see the same goes for this other column as well. So except these two columns, all the other values are in integer format, and these two values are in float format or data type. So here you can see this is all the description or information about your data that is present in your data set. So I'll just go ahead. You can use this head method to actually print out the first 5 values. Obviously, if the data set is too big, you cannot print the entire data again and again. So to analyze, things that if the data set is correctly formatted, what you do is you just print the head of the data. So the head actually contains the initial 5 rows. You can also increase the number of rows here. You can write 15 and it will print the first 15 rows here. Okay, so now what we will do actually is we will count that how many patients actually had diabetes and how many patients actually did not have any diabetes. So we will count all the values based on this outcome, right? So the outcome was actually giving us whether the person had diabetes or it didn't had any diabetes, right? So what we'll do, we'll use a value count that actually groups the values based on the column and then counts all the values in each group. So for example here, 0 means the persons that do not have any diabetes, right? So we have 500 patients that didn't have any diabetes, and we had 268 patients that had diabetes, right? So that's how you can use our value underscore counts method. So here just a disclaimer that 0 is a non-diabetic and 1 is a diabetic, right? So what you can do is next, if you want to find the mean of all the patients, like just like earlier we divided our data into 2 groups, right? The non-diabetic and the diabetic. You can do that again using this group by method, and then you can apply another method that will actually count the mean of all those values. So for example, in this group, the people who did not have any diabetes, this is the mean pregnancies of all 500 patients, and this is the mean pregnancies of all 268 patients, and same goes for all the other columns. This is the mean value of the insulin that the non-diabetic actually was taking or were taking, and this is the mean insulin value that the diabetics were actually taking, right? So it is counted out of 500 because we had 500 patients who did not have any diabetes, and this is counted out of 268 patients who had diabetes. So we'll just go ahead, and now time comes that we separate our data into input and output labels, right? We actually will divide our data based on the input and the output. So earlier I said that this outcome is actually the output of our data, right? Because it's giving us the values which are defining if the person has diabetes or if he's a non-diabetic. And all these characteristics here, right, these are the inputs based on which we are saying that this person will have a diabetes or he will not have a diabetes, right? So in the input section we will have all these 6 columns, and the output section we will have only this column right here. So you can just go ahead and you can use this drop method. You will call the data because our data was stored in data variable, and we will use .drop method here, and this drop method actually drops or removes all the columns that are present inside of these parentheses, and we are actually telling it that the columns that we want to drop. So we only want to drop this outcome variable or column, right? So what it will do, it will call the entire data, and from that data it will drop this column, and then it will store that data into a variable called x. So we'll just go ahead and print the head of this x to analyze that what we are getting into this x variable. And here you can see we have pregnancies, glucose, blood pressure, skin thickness all the way to age, but we don't have outcome here. because we just dropped it using dot drop method, right? And we will do same for the output. We will call the entire data that we stored in this variable, and then we will tell that just use this column from this data and store that column into y. And now if you just go ahead and print the head of this y, you will see that we only have this column right here which shows 1 0 1 0 and 1 0, because this 1 1 0 0 is the column that were actually giving us the outcome, right? So now that we have our data split into input and output labels, we have to standardize our data before we actually feed that data to our model, right? So for that we will import our standard scalar, right? So we will call this method here and we will store it into the handle called scalar, let's say. Now after that, what we will do, we will feed our x the input characteristics to this standard scalar method, and we will use fit method for that purpose. Now what this fit actually does is that it calculates all the parameters that we need to convert the data into standardized form, right? So basically the parameters are standard deviation and mean, and what it actually does that the distribution of this data, it actually try to create the mean that is closer to 0 and the standard deviation that is closer to 1. And what this method actually does is, after calculating, it stores all those values internally into this scalar. And if you want to apply all those parameters to your input characteristics to standardize it, we will use the dot transform method. So this method actually transforms your data into standardized form by applying all the parameters that this method actually calculated and stored internally into this variable. So we'll just go ahead and run this cell. Okay, because we did not run these cells, so actually we have to run these cells in order to get this x, and we will run this cell again in order to get our y. Now if you just go ahead and run this cell, it will not give us any error, right? So now it has calculated all the parameters, and after this we want to apply those parameters to our x, right? So we'll use this cell right here, this transform method, and after transforming the data, it has stored the standardized data into this variable. And with this command or this line here, I am trying to see that that if my data has been converted into a standardized form or not. So what we will do, we will replace the data that were present in the x. Earlier we had that CSV data, right? Now we will feed this standardized data to our x as the input, and the output will actually remain the same in the 1 and 0 format. Now what we will do, we will split our x that is input and y that is output into train and test sets, right? In train set, we will use that set to train our data to learn the characteristics based on which we will predict if the person has diabetes or not, and y is or the test set is the set on which we will actually apply that model to predict the answer of unseen values, right? So test set is actually the unseen values, and the train set will is that we will actually feed to that model. So we'll just go ahead and run this cell, but before we have to run this cell, because we have to replace our standard data, I'll again execute this cell. And here we are telling this train test split that split this x and y into train and test set format, and the test size will be 20%. That means that out of all the data that we have, convert 20% of our data into test set and 80% of our data into train set. And we have used this stratify on the output label. So let's say that out of 768 values, 600 values were for the diabetic persons and 168 values were for the non-diabetic persons. So in this case, the prediction for non-diabetic will not be so accurate because we have so less values as compared to the diabetic persons, right? So what we actually do here by stratify, we actually say that whatever the proportion was in the data, take the same proportion into our splitting method, right? So for example, how much percentage was of diabetic person in your data, put the same percentage of diabetic person in the train set as compared to your non-diabetic person, and do the same in the test set as well, right? So for that we use the stratify method. So in simple words, what we actually doing here, we are maintaining the balance of the labels that were present in the data set in our train and test set. Okay, and here this is a random state, and I have taken two values or two here. So this random state actually, if you also go ahead and use this two here, so let's say I had values, I'll just go ahead and write here. Let's say I had 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now the 20% or two values will go into test set, right? And 80% of the values will go into a train set. Now if you use random state is equal to true like I am using, then let's say if in my test set I have 9 and 10, then in your test set you will also have 9 and 10, and in your train set you will have 1, 2, 3, 4, 5, 6, 7 and 8, and in my train set I will also have the same values. Now let's say you just go ahead and change the value from 2 to 1, right? I mean just a random value, you write 2 to 1. In this case, because I was using random state, so then the values in my test set were 9, 10, but you used another value for random state, so this time the values that will be present in your test set will be different than mine. Let's say it will be 4 and 5, or it will be 3 and 2, right? So if you want to have the same elements or same numbers or values in your test set as I am, then you can just go ahead and write 2 here, right? So this is completely optional. It will not affect your model, so you can go ahead and change this, or if you don't want to include this, you can just remove this entire argument from here, right? Okay, so what you can do is we can run this cell, and we can run this cell again, and let's just go ahead and analyze the shape of the X train and X test. So our total number of rows was 768, right? Now 80% we put it in our train set and 20% we put in our test set. Here you can see 80%, 614 rows are actually present in your train set, and 154 rows, 20% is actually present in your test set. And these are the 8 columns that were present in your data set. So earlier we had 9 columns, but remember we dropped outcome column from our X. So 9 minus 1, we have 8 columns right here. So now we have the time to actually feed these values to our model, but before we have to call our model, and in this case we are using SVC, which is SVM. We are actually using SVM, so we are actually calling SVM, and from this SVM we are calling support vector classifier, and we are using linear kernel, and we are storing that model into our classifier variable, right? Now in this case what we will do, we will use fit method, and this fit method actually feeds your data to your classifier, right? So I'll just go ahead and run this cell, and I will run this cell. Now at this point your X train and your Y train has been fed to your classifier or your model. Now let's just go ahead and try to predict. So first of all I will try to predict the values out of the trained values on which I trained my model, just to analyze that how much accuracy it's actually giving, or how much it has actually learned, right? let's just go ahead and so in this cell what you're doing is you're using this predict method to actually make the predictions out of this classifier, and you're storing that prediction into this variable right here. In this cell, what we'll do, we'll use accuracy score method to find the accuracy of our model. So for that, what you can do is you can just call your accuracy underscore method. If you remember, we imported this in the start of your project from Sklearn metrics module. And okay, so right now we did prediction on X train, right? So against X train we have output in Y train, and against X test we have output in Y test, right? So if you are making the predictions on X train, then the output is obviously in Y train, right? So what we will do, we will give two arguments to this accuracy underscore method. We will give the actual output against this input, and then we will feed the predictions that our model actually made, right? And in the next line, I'm just going ahead and printing out the accuracy that it has my year. I'll just go ahead and run this cell, and here you can see it's giving me the accuracy of 78% or 78.66%, right? So that's how much accurate our model is right now. So we can actually increase the model accuracy, but there are a few steps that we have to follow. For example, this accuracy actually depends on your data. We have only 768 number of lines, so this is not a sufficient or enough data for our model to run on it, right? So we have to have a data that has I mean at least in thousands of number of rows, right? For both cases, for non-diabetics and diabetics. So in that case, when we will train our model, the model will actually have more values from which it can actually learn, and in that case our accuracy will be uplifted, right? So let's just go ahead and use this classifier on our X test values, right? So these are the values that the model actually saw when we trained it, but now X test is the values that the model never saw. So these are the new values that it is going to make predictions on. So we will predict using this classifier variable, and we will predict the values for this X test, and we will store the predictions in this prediction, right? And under it, I just printed out all the values that I mean it predicted, right? So we had 154 values. So here you can see it has predicted all the classes or labels for all those 154 values, right? So we can just go ahead and find the accuracy in the same way. And here you can see I have given the actual output, that is Y test, against this X test, and the second value or argument is the prediction that we actually made using our classifier. And I'll just go ahead and run this cell, and after that I will run this cell, and here you can see it actually gave us the accuracy of 77.2%. That is pretty good actually. I mean, if your accuracy is more than 70% or 75%, then your model is actually good. But if you will have a better data set, it will show you a very better and accurate results, right? So after that, we will just go ahead and make a predictive system. So this is nothing but a user interface, right? Where a user will enter a data point and the model will predict whether the person has diabetes or not. So for that, what we are doing is we are just creating a tuple, and in which we are having all these input values. Here you can see we have 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 values, and here you can see we also have 8 values in a data point. Now first of all, what we have to do is we have to convert this tuple into your NumPy arrays, and for that we can use np.asArray, and we will feed your tuple or your set into this array, right? And we are using this print function just to print out our array that we just created. And after that, what we have to do is we have to convert this data point into I mean its shape according to our data set, right? So for that we will use this reshape function, and in this we will give two arguments. The first one is 1 and the second one is -1. So the -1 here is actually shows that we don't know that how many columns that we are actually having. For example, here we have 8 columns, right? So we are actually not limiting it with eight columns. So we here might be, I mean, more than one or more than 8 values or more than 8 columns here, right? So we're actually telling it that we don't know about how many columns that we are actually going to use, but we do know that the number of row is 1, because this is just a one data point, right? So we know that our row is 1, but we don't know how many columns that we have in our data point, right? So it will what it will do, it will just reshape your data point according to your data set. And here you can see it has converted your data point into multidimensional arrays, just like your just like the values in your available in your data set in CSV format. Now what we have to do is we have to standardize this data, and we actually have the values that were calculated before and that are stored in our scalar variable. So what we'll do, we'll just use those variables and apply those variables to our reshape data using this transform method, right? And after that we will store the standardized values into this variable here. And here you can see this array has been converted into this array. Alright, so our data has been I would say standardized, right? Now what we have to do is we have to make prediction of that data, and after that, whatever prediction that we have, if it's 0, then we will say the person is not diabetic, and if it's 1, we will say the person is diabetic, right? So what I will do, I'll just go ahead and run this cell, and after that I will run this cell, and after that I will run this cell, right? So it made prediction, right? So our prediction was actually 1. Here you can see we have 1 in our prediction, and 1 shows the person is diabetic, so we have person is diabetic. If we made a prediction that was 0, then here it would print out the person is non-diabetic. So I think that is it for this video. In this video we actually made a complete machine learning project that predicted, based on the pregnancies and glucose level and insulin level, that if a person has diabetes or not. And for that purpose we used a machine learning classifier, sport vector machine, or SVM in short. So if you like this video, if you learned something significant for this video, just go ahead and subscribe this channel and click like on this video. Also click on that bell icon so you get notification whenever I upload a new video just like this. If you have any question or if you want to add something, feel free to go to the comment section and mention everything that you want to ask or you want to add in this video. So goodbye for now. Thank you everyone.